open close principle, and Liskov substitution principle. So these are solid design principle. So what we can do through open close principle, what open close principle states, and what open close principle provides, and in addition to that, what Liskov substitution principle states and what it provides. So open close principle, when we are finished with writing a unit of code like a function or a class, means there is no difference between function, class and module. At least if you see from Python perspective, all are kind of data structure and all are class and object. So if we are done writing the class and its method, then it is like a solid black rock which cannot be modified. So we can place in a library, compile it, and place in a library that is untouchable. So this is open close principle. If it's not that I have finished with writing the class and thinking that if anything is required, then anyway I can go ahead and I can modify it. If you are done with writing a class, then please compile and place it in a library. Or it is something like in Python, we can place it in a package, like built-in package. Whatever the classes we have in built-in, we cannot touch it. Okay, we can import it and then we can derive from, but we cannot touch it. So if we write a class and its method, then it is done. It is a black rock which cannot be touched. It should be better placed in a library. So this is open close principle. Okay. This is what open close principle states, what it provides. So open close principle, if we see, then it provides three things. Means three ways a class can be modified. I mean, class cannot be modifiable. It should be closed for modification and open for extensibility. So once class is placed inside a library, that class cannot be touched. But what the other thing that it states and provides. So class should be extendable. If I have a class in a library, then I can extend it. So whatever the method, it should be extendable. It should be overridden, and we can kind of use it. Okay, so extend it, then we should override it, and we should be able to kind of use it. So extendable in a fashion that if a class has a methods, then we should, if I derive from the class, if there is a class, if I derive from the class and it has methods, then I can add more methods to it. So this is called extendable. The class is extendable because I am going to add more methods to it. So this how why I need modification. That question comes. If I am done with writing a class, which all other places where which are the kind of hooks where I need modification. So one modification reason is I need to add methods. Okay, derived from the class, and subclass can add methods. So it is extendable. Overridden in the sense whatever method I have written, I should be able to kind of rub it. If I have a method called func, then there I need another func because whatever I wrote that was completely absurd or it is not useful in the current scenario. If that is true, then I should be able to override the function and write my own function. If someone calls through the base class pointer also and calling the same method, then my method, the subclass method should be called. So a function should be class should be extendable. We should be able to add methods, and we should be able to replace the method. We should be able to use the method in case we want to extend function. We were extending class. Now there is a function called func. I want to add something there. Then I should be able to call the parent function and then add the code. It is like a decorator. So I have parent function anyway with me prior to the function, calling the function, and after to the function I can add the code inside the same function. So three things open close principle states. When you write a class or a function, please place class or function in a library or in a package so that you should not touch it. Okay, how you can add methods to it? You can derive from it and you can add method to it. If you want to completely replace a method, you can override the method, or if you want to modify the method, then you can override, and then you can add the code and call the parent, call the base class function, and then you can add the code again. This is like a decorator design. So three things that open close principle states: close for modification, open for extensibility in this fashion, that you can extend a class, you can extend a method, or you can replace a method. Where is the problem? Okay. So if I am extending a function, then where we should be careful. So there Liskov substitution principle. Okay, so it is like close for modification, open for extensibility. Whatever the extensibility, open close principle state, there are more extensibility that is required. So that extensibility is provided through Liskov substitution principle. So if there is a base class that is written, then base class is someone has written program. So there are two things when we write the program. One is called service component and one is called client component. Client component depends upon the service component. Client component write code based upon the service component pointer. So if someone has written code based upon the service component pointer, sub service class pointer, and this is service class, and from in future new things arrives, new functionality arrive, new implementation arrive, new algorithm arrive. If that is the case, if this is the service class, we derive from the service class, and now in the client component, wherever I have written, everything is closed for the modification. Client code is written. This is client code. Client code has a function, and in the function parameter, it takes service class pointer as a parameter. Now, based upon the service class pointer, full algorithm is written. Now, service class pointer should not change, and class client components function should not. All everything is closed for modification. If that is true, then from the service class, if I extend the service class in future, because few methods in the service class are written in better ways. Now, if the subclass object, if I pass in the client components function parameter, everything should work as it is. This is called Liskov substitution. The subclass, base class, subclass. So base class of the client of the service component, subclass, sub wherever the service component class is used in the client component, it should subclass should exactly replace it. So this function should be called exactly the way it was working earlier. It should be unknown that new object has come, conforming to the same interface. So if subclass that derives from the base class and the subclass object is going in an algorithm where base class pointer is passed and everything is written based upon the base class pointer, then subclass should exactly replace it. If that is true, then this is Liskov principle. Like take example, I have my favorite motorbike. So in the early morning, now I call a function against the motorbike. If it is dirty, then wash. Take it to gas station. Okay. So take it to gas station. Get petrol filled. Go for ride. These are the methods. If is dirty, wash it, take take it to gas station, get petrol filled, ride it. You can have other method like brake, pull brake or uh, drive through handle. So these are the methods. So client component is getting motorbike pointer and it has written algorithm based upon this. Tomorrow, motorbike is old and I have a new motorbike that is electric motor. Now, electric motorbike object I am passing to the client. It should not work. And the deriving from the motorbike uh, to electric motorbike that itself has a concern because I have to override, I have to provide a few functions. So if motorbike is not interface, then anyway I am not forced to provide the override the function. Let's consider that motorbike that is the base class that is not interface. So what the electric motorbike provide the function. Now in the client algorithm, if it is dirty, very nice, then clean it, wash it. Probably you may not wash the electric vehicle. You see, electric vehicle. You may clean it, but placing water everywhere may not be feasible. So there is no function called wash it here in the electric vehicle. So the client code would break. Then you take it to gas station. Okay, get petrol filled. There is no petrol you need inside there. Then go for ride. It's all right. And pull brake and take use handle and accelerator. Everything is all right. But few functions are not there. So this do not follow Liskov substitution principle. Liskov substitution principle, when you write a class and use the class in the client component to its pointer, if you derive from the class, derived object should be called same way the base class was called. It should exactly substitute. But a petrol motorbike cannot be exactly substitutable by electric motorbike. So it is not following. So what we are getting, if you see the open close principle, we are following open close principle. The motorbike is closed for modification. Client code is more closed for modification. We derive from the motorbike, but it cannot provide it cannot override all the methods. So the way the motorbike class was written was not perfect. So when you write the base class, at that time you think about the generic thing. So is dirty nice? Wash it. Rather than you can write a function called clean it. Take it to gas station nice, get the fuel rather than get the petrol. Now it's all right. Now the electric bike can object can go in the client service, client code, client component. Now it will call if it is dirty, clean it. Go get to gas station, get fuel filled. So electricity will get filled. Go for ride. So when you write a program, a class in service component, then please take care that whatever method you write, it should same method should be available in the future if it is subclass. So that is risk of substitution. Derived class should exactly replace the base class. Now, what can be other problem? Suppose that I am providing same interface, same function. Now, if it is dirty, then clean it, go to gas station, get fuel filled. But it is throwing exception. The derived class is throwing exception, whereas base class was not throwing exception. It is returning something different. Base class of methods were returning something different. It is returning something different. Okay, even though method names are same, but it is throwing exception. If it is throwing exception, that is not so. It should be exactly substitution. If base class is not throwing exception, derived class should not throw exception. If base class is throwing exception, derived class should throw exception. That the exception should be polymorphic. The exception also is a class, right? If base class throws exception in a method, the derived class must throw same exception or any exception that is subclass of those exceptions. If base class returns something, those return types should be a class that should be polymorphic, and derived class should return same class or derived class of the parent class. So if this is base class in service component, if base class has a method and it throws an exception E, then derived class method must throw exception E only or E subclass. If base class method returns a pointer of A, then derived class method must return pointer of A or subclass of A. Then only it is substitution. So we must, whenever we write base class, we should not, first we should think about the method, and whatever we are doing inside the method, everything should be polymorphic. Then only it is substitution. So open close principle, class should be extendable, method should be extendable, and method should be replaceable. But not only that, okay, so if we see the Liskov substitution principle, the base class completely should be substitutable by the derived class. Then only it is, I would say, it is really a open close principle. So whatever was hidden or implicit or it was not there, that is filled by Liskov substitution principle.